Okay, good morning, dear students. First of all, I just introduce myself. My name is Nivin K. as Assistant Professor in Srinivas Institute of Technology, Mangalore. Today, we will discuss about the fourth semester BE students, I mean BTech students, VTU under BTech students, fourth semester. That's one of the important core paper. I mean CSC, Computer Science, allied branches. All the allied branches, one of the main common core paper. Design and analysis algorithm. That's the subject is design and analysis of algorithm. The subject code is 21 CS 42. Okay. So one of the main core paper. Now today I will be plan to discuss about the second module, one of the second unit's important topic, graph searching algorithm. Yeah, previous semester you already studied the one of the important paper 21 scheme data structure and its application. That data structure is the one of the graph is the one of the main data structure and a tree and etc. So many data structures are in the data structure algorithm already. So many data structures are in the in their computer science. Okay, so this graph searching algorithm, the one of the important algorithm in tree, graph, and so many data structures, because searching one element which find out the simplest path and shortest path, and so many application will be using this graph search algorithm. Graph is containing multiple number of nodes and edges, I mean vertices and edges. Okay. Basically, two search algorithms are in normally in graph and tree, BFS and DFS mainly using. One is depth first search and another one is breadth first search. Today I will plan to discuss about only one, DFS, depth first search. Okay, that is one of the important one. We just discuss about what is the exact working and what is the exact implementation of DFS. The DFS is the one of the main algorithm. The DFS algorithm start as a source node. What is mean by source node? The each graph having one of the source node and a destination node, because that based on the that application. Okay, we just find out the one of the source node, then that source node everybody know what is the graph structure and what is the tree structure. One node connected to another, so many neighbor nodes or adjacency nodes is there. We select a one source node that directly connected to another, so many adjacency or connected nodes is there. Okay, now visit all the nodes connected to it and then move the next unvisit node. We selected a one source node, then we just go to another unvisited node. That's a neighbor node or adjacency node. Okay, it repeat this process until the node is in the graph have been visited. All the nodes visited, this step is continuously repeated. Okay. Now, DFS stands for depth first search. It is a one of the fundamental algorithm for graph traversal. Okay, and BFS is the breadth first search. Depth first means depthly searching. Depth first search. Okay, it is a technique used to explore all the nodes or vertices. What is the nodes or vertices? Oh yeah, everybody know the what is a node and vertices. This is a combined of so many nodes in the graph is created. The vertices of graph in systematic manner. All the nodes visited one by one in systematic manner, starting from particular source node and moving to possible for each of the next node. And anything, one of the backtracking process is there. Anyway, we just check the visiting node to any other adjacency node is node there. That time to backtrack to parent node. That's a common working of backtracking. Okay. Then DFS is a strategy for searches deeper. I am already know depth first search, and the data structure stack is using in the depth first search. Okay, we just go to next slide. What is the exact working? Basically, step one and step two and step three is the main processing. First of all, I already tell that what is the exact working. First of all, we just find out the source node. Any node in that graph, we just find out the source node. Then source node do just find out the connected adjacency nodes are there. Okay, we just go to that way. Okay, first of all, we just start from a source node. We just choosing one source node. That's a step one. The step two is visit the node. Then you just find out the source node. Then find out the next one. What are the adjacency nodes of that source node? Then directly go to visit that node. Okay, then connected nodes, all the adjacency node you just visit and explore the all the nodes of that graph. Okay, that based on depth first search. Okay, this depth first searching working time, normally two arrays are already running. That's a behind stack array and the normal visited array. Okay, the all the traversal elements are pushed into visited and visiting all the nodes one by pushed into stack, and then all the visiting after just one by one pop out. Okay, then this process is continuously repeated to get a one traversal code, I mean traversal path. But one sometimes I already explained what is the exact meaning of backtracking. Sometimes we need for backtracking because we just A, B, Z, D. The D is the last node of the graph. We have a no other option. We just searching another any adjacency nodes of D, but that time no adjacency nodes is there. That time just we just backtrack to parent node. What are the parent node is beside? Just directly go to that node. Okay, that's a backtracking. Okay, backtracking no adjacency node, that time the backtracking, the repeatable step and 2 to 5 and continuously this all the nodes are visited. And one example is next, we just discuss about the example. Suppose we have a following graph. This one is the one example. This is A, B, C, D, F. This graph is working. We just explain now. First, the first node is I just choose source A. Okay, source node is A. We just explain the next side all things, but we just go to one by one. The first we just select the source node A. Then I directly choose B and C directly push it into stack, but I'm not visiting, just to push it into stack. Then next pointer is point out. I mean stack is what is the exact stack working. Last in first out is the stack working procedure. So pointer is point out B. Then B is directly pushed into visited array. Okay. First of all, A, B, Z is already pushed. B and Z is pushed into stack, but we just point out only B. Then B is pushed into visited array. So that is the second step. We have first visited start, A is visited, and then what is the neighbor node of A? Then directly visited to B. C is already pushed into stack, but directly go away one by one depth level, because A to B and C is already pushed in the stack, but A to B then directly go to D. That's a depth first search. Okay, then B is point out to it. Then next we just select the what are the adjacency nodes of B. That's the third step. What are the adjacency nodes of B? What are the adjacency nodes? D and E is there, but E is pushed, D and E is pushed into stack, but directly go to D only. That's the depth first search. Okay, then D is the next neighbor node of B. Okay, then we have any other unvisited neighbor node, then backtracks to parent, because one of the third step is there. D is checking any another adjacency node is there. No, that time to backtrack to B. That's the fourth step. We have a no more unvisited backtrack to parent. Okay, then next E. B is directly go to E. That's B is another one node is already there, adjacency node. We already visited D, then backtrack to B, and B's adjacency node is E. Then once again visited E. Then E is checking any adjacency nodes is there. No, E is having no adjacency node. Then directly go to backtrack to B. Okay. Then B all the adjacency nodes we visited once. So we have a no another adjacency nodes is there. We just go back to A. Okay. Then A is already pushed C in starting. So we just selected the adjacency nodes of A, C. Okay, that C is already visited. Another unvisited C is visited. Okay, sorry, which no more unvisited backtrack to parent A visited A, B, D, and another unvisited A is as another unvisited neighbor is C visited. Okay, then we just check the what are the adjacency nodes of C. C is our only adjacency nodes F that pushed into stack. Okay, then next F is checked any adjacency nodes is there. Okay, F is checked any adjacency nodes is there, because already C is visited. C based on F is visited. F is checked any unvisited node is there. No, because you just check is this one. F have a no adjacency node is there, so empty. Then backtrack to C. Okay, backtrack to C. That is already here. Backtrack to C. Okay, the A, B, D, E, C, F. That is the traversal of DFS based on that graph. Okay, that's as a no more unvisited neighbors. So DFS is complete. DFS traversal or A, B, D, E, C, F. This working is like a first of all we just pushed a unvisited array, visited element in element or node is A. Then B, C is the neighbor node, but we directly go to B. then directly go to, we check the D and E is already neighbor node, but D and E is pushed into stack, but we selected a visited element is only D. Then D is checking any another adjacency node, no, then backtrack to B, and B's next element is E. E is checking any another adjacency node, no, then directly backtrack to B. Okay, now A, B, D, E is okay, then backtrack to B, then B have a no adjacency node, all the nodes are visited, then backtrack to A. Okay, then already A have another left adjacency node is there, C. We just pushed C into visitor node, then C is checking any other adjacency nodes of C. Okay, F is there, then F is checking any adjacency node, no, then backtrack to C. Okay, then that's the traversal is over. A, B, D, E, then directly go to A, but A, B, D, E, C, F, we check it. A, B, D, E, C, F. This is the one of the simplest example of DFS working. Okay, thank you. Tomorrow we'll come to the another topic, breadth first search. Okay, thank you.